All right, let's dive in. Today, we're doing a complete breakdown of a really cool project, a line-following robot built specifically for restaurant management. We are going to tear this thing down piece by piece and see exactly how it works. So, let's get into it. So picture this. You're at a super busy restaurant, right? It's kind of chaotic. We see automation everywhere, in factories, warehouses. But what about at our dinner table? Could a robot actually make your dining experience better? Well, that is the big question this project tackles head-on. And here's the answer. Yep, this little guy. This isn't just a drawing or some fancy concept. It's a real working prototype. It can navigate on its own, it has a way for you to interact with it, and it talks to a server in the back. Pretty cool, right? So let's see how they pulled it off. Okay, first up, the robotic waiter solution. The whole idea is simple but brilliant. Think about one of the most repetitive jobs in a restaurant, taking an order and running it to the kitchen. It's where mistakes happen. This robot automates that single step. And the result? Things get faster, there are fewer errors, and the human staff can focus on, actual customer service. So how does it actually do it? Well, it really boils down to three main jobs. First, it has to get around by itself, following a set path. Second, it needs a way for you to place your order, in this case, a simple keypad. And third, and this is the magic part, it zaps that order over Wi-Fi straight to a web server. That direct shot to the kitchen, that's the game changer. No more delays, no more oops, I wrote that down wrong. All right, section 2, the anatomy of the robot. Let's pop the hood and see what this thing is really made of. We're talking hardware, software, the whole shebang. Every great hardware project starts right here, with a blueprint. This is the circuit diagram. It's the clean, perfect plan showing how the brain, the muscles, and the senses all talk to each other. This is the on-paper ideal. And here we go, the plan versus reality. Anybody who's ever built anything knows this exact moment. On the left, you've got the pristine schematic. On the right, well, that's the beautiful, chaotic reality of a working prototype. It might look like a mess of wires, but that is where the magic happens. This is turning a drawing into a real, moving machine. Okay, let's look at the key players here. The ESP32, that's the brain. And it's a smart choice, not just because it's powerful, but because it has Wi-Fi baked right in. Super important for this project. Then you've got the L298N motor driver. Think of this as the muscle. It takes the tiny signals from the brain and turns them into enough power to actually drive the motors. The IR sensors, those are the robot's eyes, letting it see the line on the floor. And of course, the keypad is how customers talk to it. So how does this thing actually follow a line? It's a classic for a reason. It just works. The robot has these little infrared sensors pointing down. They're constantly asking, am I on the black line? If the right sensor sees black, the robot knows it's drifting too far left, so it steers a little to the right. If the left sensor sees it, it steers left. It's this constant little dance, back and forth, that keeps it locked right on the path. Now, all these electronics need a home, right? And that's where this custom 3D printed chassis comes in. For prototyping, this is perfect. It's light, it's strong, and you can design it with perfect little spots to mount every single component. It's a great reminder that a killer robot isn't just about code and circuits. The mechanical design is just as critical. Okay, part 3. Let's walk through the order-taking workflow. We've seen the parts, now let's see how it actually does its job, step by step. So the robot's mission has 5 phases. First, navigate. It follows the line to your table. Second, detect and stop. A special sensor sees a marker on the floor that says, hey, you're at table 5, and it pulls over. Third, await order. It just chills and waits for you to punch in what you want on the keypad. Fourth, transmit data. You hit enter, and whoosh, the order is sent over Wi-Fi to the kitchen. And finally, step 5, return to base. Job done. It heads back home to get ready for the next one. And this right here, this connection between the keypad and the ESP32, this is really the heart of the whole operation. Every time you press a button, it's turned into data and sent wirelessly. It's a direct, unbroken line from your finger to the kitchen's order screen. That's the bit that cuts out all the manual running around. Okay, let's talk about why a project like this is so important. This isn't just some homework assignment. When you build something this complex, you're building a portfolio of skills that employers actually care about. This is how you go from, I know the theory, to, I've actually done it. And just look at this list. This is a tech stack you can be proud of. You're not just coding. You're doing microcontroller programming on an ESP32. You're integrating sensors and controlling motors. That's the core of robotics right there. Plus, you're dealing with Wi-Fi, HTTP, putting all the systems together, and even designing and 3D printing your own parts. I mean, every single one of these is a skill that's in high demand. And that really sums it up, doesn't it? A project like this is the whole package. It's not just hardware or just software, it's everything working together to solve an actual problem you can see and understand. It is the perfect launchpad if you're serious about this stuff. So, as we finish up here, think about this. The point wasn't just to build a robot waiter. The point was to master the process. Sense the world, process the information, and take action. That's the formula. You can apply that to almost any problem out there. So the real question I have for you is, what problem are you going to solve next?